using the stupid tablet microphone. Okay, 10-2, we are going to do regressions in this section. Well, oh, I got to find the mouse. I wish everything was, oh, there it is. Okay, so the value of the correlation coefficient is significant. The next step is to determine the regression line. So remember, those significant values are usually above whatever that test value was, above or below in the right area, critical, not critical for the correlation coefficients that we were finding yesterday. Okay, so it's just kind of like which one is a better fit. So we've already found these regression lines. We already really know how to find the regression lines. And I figured out how to make the calculator do our regression lines, but I forget it every single time. So I will show you how, and then we'll have to like find some sort of remembering type of thing for this. Okay, the best fit, when we talk about our best fit, we've already really done that. It's just we want to minimize this distance here. Okay, so that's what we did on Monday, is where we minimize the distance of the squares, because these really all make little squares. So that's what we were doing Monday. Okay, so the best fit is the minimum distance from like all of the lines together. Okay. Did it do anything? Yeah, it did anything. Okay, so the regression line is this big gross thing. We're letting our calculator do this, so don't freak out about this. Okay, what we need to know is this piece, our line, A is the y-intercept. What?
Is that y prime?
I guess it's y prime. I don't know why they have an apostrophe on it. I guess, oh, probably just because
really
it's
cool
an estimate.
I knew what that little thing meant.
Okay. Okay, A is just the y-intercept, B is the slope. So that's kind of backwards. I don't care if you write mx plus b instead, because you're still going to be inserting those in. So your calculator, again, is just going to do most of this for you. So we're not worried about this big gross equation, but know that those big gross equations are there if you had to do it by hand. Okay, find the equation of the regression line for the data example in 10.4 and graph the line on the scatter plot. So the data example is, so they give us all these things. Do we still have 10.4 in our calculator? Because that would be cool if we did. And we don't. So that was, so for 10.4, that was the car company and the cars and millions in revenue. So we did that one yesterday. And sorry that I'm having to yell. It's using that microphone and I feel like I'm yelling a lot. But I just want to make sure it hears me good. So what we did yesterday with that example is we found the correlation coefficient. We're just letting the calculator do that stuff for us. So this would be under that Lin reg. So we would find all of this stuff by doing the, what button is that? Stat. So we would go to the stat button. I didn't turn it on really. And then I'm going to go to the calculate menu. And then I'm going to the Lin reg. Oops. Capital L. And it looks like AX plus B. So this is what the thing actually looks like. It on mine, it's the fourth option. I think it should be the fourth option on everybody else's too. And that's going to calculate the A and B for us. And also, again, if you don't have the R and R squared, make sure you turn your diagnostics on. Which you find in the calculator catalog. Okay, and that will give us the R and the R squared as well. Okay, if you don't have the R and R squared, or if you don't have the diagnostics on, it will only give you the A and B numbers, and it will not give you the actual regression lines, which is what we needed for the first section. Okay, after the calculator is going to basically only give you, it's going to say y equals ax plus b. Is that readable in there? Not really. And then it will say A equals, B equals, R equals, and R squared. Not sure about all the orders, okay? But then you need to write it back in this form. So make sure it actually looks like an equation that you would normally write. Okay, so No, we're gonna just let them do the work for us because all of this requires like tons of calculator work stuff. Find 2 points to sketch the graph of the regression line. I want you to actually do it in the calculator and then kind of actually use it. So they use 2 random points, which is kind of what we did like algebra 1-ish time when you would just, okay, I have all these dots, I'm going to pick this dot and make it go through that. I don't really necessarily want that anymore. So I mean, like, yes, that kind of. But what I want is I just want you to go then type the equation that you wrote. So you wrote this equation, and I want you to type that in your y1 on your y equals. And then, so you would just write that and you'd actually come up with the graph. Okay. Okay, so this is what you'd have from the stat plot, and I want all your points on there with it as well. Okay, those 2 points are the random points that they picked, and then you draw the line through those 2 points. Oh, okay, so they just picked 2 random points, so that would have been okay to come up with the value. But again, we're going to use our calculator. And I will walk you through steps, I guess. Taryn, I'll probably show you in the morning. Sean, I'll show you tomorrow morning too. Okay, if you need help with the calculator anyway. Income, I want to find a different thing. Okay, I guess that's the next example. I wanted to find one that had all the data, but it just uses all the stuff from the day before. Okay, so marginal, the magnitude of the change in one variable when the other variable changes exactly 1 unit is called the marginal change. I always remember Miss Simmons made you guys do like a unit rate, finding a unit rate, that's finding the marginal change. What? You didn't like that one? Okay. The slope of B of the regression line in the equation represents the marginal change. For valid predictions, the value of the correlation coefficient must be significant. Remember, that's pretty high, so at least above 0.7 or below negative 0.7. When R is not significantly different from 0, the best predictor of Y is the mean of the data value. Okay, not significant, it's the mean of the datas. For valid prediction, so you guys always remember your equation Y equals mx plus b?
Every day I come home with like marks on my elbow and I have no idea how it happens.
Now you know. Okay, m is marginal. Okay, so Y equals mx plus b, that's all that m means on there. I think I always used to wonder what the heck, how we came up with these random numbers, but that's actually where the m comes from. Okay, for any specific value of the independent variables, Y must be normally distributed along the regression line. So that is just some weird graph things going on. I haven't been clicking through here. I'm sorry, I haven't been clicking. Okay. Yeah, that's just weird to look at. Stop it.
Can you just behave?
Okay, so if I had all of these little data points, I would have lots of them. So the standard deviation of each of the dependent variables must be the same for each value of the independent variable. Okay, I don't know if they can get much more confusing than that. I'm sorry. I'm sure it can too, actually, yeah. Let's try.
I'm using the crap out of Tom Day right now. Because I told him, hey, wear a black shirt and a silver vest. And then I was like, hey, wear a white shirt and a silver vest. And he's like, do you want a white one or a black one? And I was like, well,
you should just bring both
I
so
want
that
a
I
white
can change
one.
my mind.
Yeah.
Okay. Extrapolation or making predictions beyond the bounds of the data must be interpreted cautiously. Okay, so usually, like, I don't know, do you guys kind of remember in college algebra and I would make you come up with some random equation for the data? We did it a little bit. And then make a prediction about what would happen in the year 2000 because, like, the book was old. You can't always do that. Most of the data, when I have a curved line, so if I'll try not to write on this. So if I have some random data that look like it goes in a pretty straight line, Okay, so this is my random data. So if I only look from here to here, I can put a nice straight line through that. Okay, if I'm coming backwards in time, if I'm trying to look, hey, what happened at this time, it's negative. That's not even a thing. Like, that's not going to work. So it would only work for like here to here. But also, maybe I didn't have like the whole picture of the data. So if I zoomed out and then I saw like this thing, which it would be kind of more exponential growth, a linear would only fit a little bit. So I would have to have this exponential function. So a linear thing wouldn't have been a good fit. So you can use your equations to make those assumptions later on, but they can't be like too big of a gap, because if I had done between here and here, that probably would have been okay. It still is kind of pretty close to the line. But if I had asked you about something between this time and this time, like that's just crazy, not even close to the line, that's like a really far distance from all of them, so that just doesn't work well. Okay? Remember that when predictions are made, they're based on present conditions or in the premise that the present conditions will continue. This assumption may not prove true for in the future. Okay. We already know how to find that. We're using our calculator. Okay. So that is pretty much it, and I don't even know. Is there a hypothesis testing with this guy?
I don't know, but it's 11:18.
Yeah, that's crazy. So you're gonna say, is R
He has what?
significant? Positive, so it asks you like positive, negative, so it asks you just lots of different questions about that kind of stuff. So mostly it's just gonna be typing stuff in the calculator. And if R is significant, you're gonna find that regression line. And did I put numbers up? I hope I put numbers up yesterday. Let's actually do a lot of problems too. Let's do
No, I'm stressed.
1 through 15
I'm
odds.
stressed, but now my date just told me he has mock interviews in Sterling that day that day.
Sweet.